we're going to look at is the cone penetrometer data. And so you have access to this spreadsheet from Blackboard. So here we have this Brookhaven CPT template, and so that's what we're going to be working with. So if you open up this is a cone penetrometer boring log, or cone penetrometer log from the Brookhaven site. And so look at this over here. It's going to be good enough for our purposes, but it seems that I've moved that down a little bit. I'm going to reset that just a little. If yours aren't set up like this, that's fine. I think yours are gonna be pretty close. And so what you can see over here is that you have these orange points over here. So those are all 0 values. And so what you can do is you can come over here and you can start picking off these points. And so for the tip resistance, we're going from 0 to 600. So this looks like about 25. And you can see as I'm putting these numbers in, they are popping up over there on the left. And this takes a little bit of sort of trial and error. So I'm just gonna, like that's probably, I put in 70. Maybe this is more like 50. Okay. And the next one maybe, 125. So I'm just kind of going through here and I'm kind of guessing what these values are going to be. Looks like I missed this one over here. And so I'm just interpolating what the values are. So I'm kind of familiar with the data there, so I went through it pretty quickly. Then you do the same sort of thing for your tip resistance. Okay, so I put in some values, and you might have slightly different values. And so what this thing does then is it does all these sort of calculations. And what we need to do is we're going to need to compute what the stress is, and so we have to come up with some sort of unit weight. So I'm going to use a similar one to before, and then we have to determine what the water depth is. Well, this one over here, the water depth is given, and you can see that there is your line, so I can insert a shape, and I can measure what that water depth is. So I'm just going to put in a line over here, and then I'm going to format that line. And so now that should be a straight line. I can take that, I can drag that over there, and that looks like it's 28 feet. here, I put in my water depth, 28 feet. Okay, and then so I've entered the values for the QT and the F sub S over here. Should move that over here. This is where that's going. And then we do this iteration. Well, in order to do the iteration, we start out with an n value of 1. So here's the n value of 1. And then, so that is in column, sorry, here's your n value of 1. So that's in column AU. And then what we do is we copy paste special the old values into, I'm sorry. Once we have that, let's walk through my instructions here. Start with n is equal to 1. So that's in column AU. So here's column AU. And then we have n is equal to 1 in column AZ. Okay, step 2. Copy paste special values n new column AY over here into the old value. So I'm going to go over here. I'm going to copy those. And then you have to paste special. So you go paste. And then you can do special values over here, and then I'll just take the values, put them over there, and then also you copy paste special values into your column AU. So look over here, paste special values right over there. Okay, so now what we have is we have this is our n new, and this is our previous value, and then the delta between the two is calculated over there. So that needs to be less than 0.1, and so what we'll do is we'll just repeat the process. And so we can once again go back up here, and then we say that we are going to copy paste special the values in the new value into the old value. So we go over, click the new one, and we put this in the old one. I can also right click and go paste special values. Paste special values. Okay. And so now our we've iterated within that 0.1, and so we are fine. At this point we've solved for our values. Okay. So now it's gone through and it's done the classification, and this is a lookup table just like we did for the CPT. Now the only question is, what is your relative density? So we're going to go with an over-consolidation ratio of 1, and then we have a little bit of guidance over here off to the right on how to figure out what this Q sub P is. And so if you come over here, or Q sub C rather. So compressibility factor is 0.91 for highly compressible sands, 1 for moderately compressible, 1.09 for slightly compressible. So looking at the previous analysis, it looked like their soils were pretty dense, and so I'm just going to go in and I'm going to make the assumption that this is 1.09. If you select something else, you'll get a slightly different number. And then from that, we have our relative density. And then this is the low and the high and 60 values, and those were calculated if I put those over here, if I just put those in my lecture notes. See, here we go. So those are down here at the bottom, and this shows how you would calculate these. So based on your grain size, which we were estimating somewhere around 0.6 or so for our grain size, then this is going to calculate the ratio of your tip resistance to that N60. And so once you know what that ratio is, then you can estimate what your blow counts are. And the purpose of this is just to get you in the ballpark to see kind of what kind of blow counts you might expect to see from this type of material. So the cone penetrometer is not going to give you exact blow counts, but it'll give you just a general range. And then you can go back over to your CPT data and see, did we see blow counts kind of in this range? And then finally, you can do a similar plot to what we did with the standard penetration test, where you can plot your vertical stress versus your cone bearing, And so from that, this is telling me that I would expect to see a friction angle somewhere around 44 degrees. There's a couple higher values over here. So it looks like the CPT is telling me that I might have a little bit more friction. But the other thing is you might notice here is just how consistent this data is. If you look at the standard penetration test data, the data tend to bounce around a little bit. And so one of the nice things about this is that it tends to give you a consistent set of data.